Hi guys. As you said, my name is Maíra, and I'm a front-end engineer all the way down in Brazil. So, and right now I'm here to introduce to you a little bit about Metal.js and Crystal components. So before I delve into that, I'm sure that, like many of you have never heard of this before. Maybe you're hearing about this for the first time, and this is falling. It's hard to be a girl presenting. The hair gets in the way. Okay, so I think this is fine. So before I start talking about what Metal.js and Crystal components are, I just wanted to give you a quick introduction of just how JavaScript has been evolving inside Liferay, so that I can explain to you why we're working on this project and what it is. So Liferay as a company, it has started all the way from 2004, right? And since then, since we have a web product, and JavaScript has been improving and has become a very important part of web products today. So as JavaScript has improved, so has Liferay code had to improve as well to keep using the new features of JavaScript. So in the beginning, when we started having a lot of JavaScript code, no one wants to deal with raw JavaScript, right? You need to know, you have to have a core library that you trust, and that will work with all browsers. And this won't stay. Wait a little bit. Okay, I think it will stay there now. So in the beginning, when Liferay started, it's been a long while. Can you still hear me? That's fine, right? So in the beginning, jQuery was very popular. So it worked on all browsers. It worked well. At the time, everyone was using jQuery. And that's what Liferay started using back then. So jQuery and jQuery UI, which were the components built on top of jQuery, right? So that's what Liferay components were made of. And Liferay code, JavaScript code, was all based on jQuery back in 2008. I think it was the first version that came already with jQuery and jQuery UI. But as I said, JavaScript evolves really quickly. And then with time, new libraries came up and new technologies. And then jQuery became a little bit outdated for the use cases of Liferay. So for example, YUI is a library that came up at a time. And they had a lot of interesting features that jQuery didn't. So for example, the module system, where you can inform your dependencies for JavaScript, which is something that all JavaScript developers need nowadays. We can't live without this on a big code base, right? And YUI offered that. And that was pretty big news at the time. Today, it's more normal to see this. But for YUI, when YUI came up, this was a big thing that they offered. And besides that, they also had a very good architecture, more defined than jQuery had. So for this and other reasons, we decided to port everything we had to use YUI instead. So we rewrote all our jQuery components into YUI, right? But then on version 6.0, instead of coming with jQuery, Liferay already came with YUI. But what happened with jQuery also happened to YUI in a few years. So that's what's always happening with JavaScript nowadays. So new technologies came up, new libraries came up, and YUI couldn't keep up with all that. So YUI was built by Yahoo. I don't know if all of you know that. And something that happened really recently is that, which wasn't unexpected in the end, is that last year, YUI decided that they weren't going to maintain YUI anymore. So Yahoo isn't maintaining YUI anymore. We can't, and we depend on it, right? So our components are all built on YUI. So what happens is, now we don't want to keep using YUI, right? Like, it's already outdated, and now it won't be maintained. So that's a very dangerous thing, to keep using a code that's not going to be maintained. Okay, so the big question now, and the reason why I'm showing you this, is what are we going to use for Liferay 7? We need something to use that we can trust this time, and we can't keep using YUI now. So there are definitely lots of options that we can use. There's Angular, Ember, React, Backbone. just to name a few. And then we had to sit down and just like decide what was going to be the new foundation for our components now. Okay, so one thing that we realized is, okay, we got to pick something new, but for how long is this new thing going to keep being new for us, right? So I think that's the big thing with JavaScript today. It's evolving really quickly, like we already saw happening twice with Liferay, with jQuery and YUI. And if you see here, you can see many frameworks that are being built, and they're really quickly coming on top of each other and gaining popularity. And some die, and new components, new frameworks are coming up every day. So it's really hard to choose one. And we're afraid of doing the same mistake again, right? Because if we choose React now, for example, and in a few years, it's obsolete, and something new is the new thing. So that's always a risk. And on Liferay, it's a bigger risk, right? Because we have a very big code base, and we need to rewrite everything another time if this happens again. So we don't want this to happen. Another thing that we've noticed is that these new libraries, they're very big, right? And this is a problem for Liferay as well, because whatever library we choose to use on Liferay, that library is going to be on all our clients' codes as well. Right? People are going to use Liferay, and that's going to be included on their sites. And then there's a problem, because if we add a big dependency, that's going to be a big dependency for our clients. And we have to also think that whatever library we choose, we're going to have clients that chose another one. So they are going to have both libraries on their sites. Or either that, or they have to change the one they're using to use the one we picked. And that's not good, too. We don't want to put people on this compromise of having two big libraries. Yeah, and the reason that these things are very big, these libraries are very big, one of these reasons is that they have too many features, right? We don't need all the features that these libraries bring to us. So for example, Angular and Ember, they have routing features for single-page applications. But we didn't use YUI for that. We had Senna.js. I don't know if you know this project. It's a project that we use inside Liferay, a very small library. And it does exactly that. It does the routing and the single-page application part of Liferay. And that's a good thing, right? Because if we were trusting YUI to do this somehow, we would have to rewrite that as well. So it's a good thing about this modular approach. Instead of adding one big dependency, we like to add smaller dependencies that are focused on what they should be doing, instead of doing everything at once. So that we don't depend on only one thing, and then have to replace that, everything again, when something changes. Instead of that, if we add modular pieces, we can just replace the thing itself instead of changing everything again. Okay, so even though it has more features than we want, they're also missing some features that we want. So, for example, the file dependency management that I mentioned from YUI, it's not present in all these new libraries. So it's something else that we would need to add, and it's very important for us on Liferay because it's a big code base. And it's crazy. It's a nightmare not to use this nowadays. And another thing is progressive enhancement. So just to explain very quickly what progressive enhancement is, basically, today we have very heavy client-side applications, right? So most of the rendering many times is done on the client for a website. And what happens many times is that when the user opens a page, it comes out blank because the server doesn't render anything. And then only when the JavaScript loads is the page shows something, and it can see and act with the page, right? So the perceived performance is very slow for pages like that. It takes a while for the user to even see something and then to act on it. Progressive enhancement is a technique where you do hybrid rendering in this way. So the server, instead of giving a blank page that the JavaScript renders, the server also renders the page, gives it with some markup already that the user can see, and then the perceived performance is a lot better because it sees actually something when it loads. And then when the JavaScript loads, it just adds behavior instead of rendering everything again. Of course, JavaScript has to render something later so that we can have single-page application. but this hybrid rendering is really important for perceived performance. And that's progressive enhancement. And some libraries help with that, some libraries don't. So it's really hard to find a library that does just what we need, so that it's small enough that we can put on Liferay. And at the same time, they don't have all that we need. So we need to add more. So these are the main reasons why we decided to, instead of using popular library, the most popular library today, we decided to build a very small thing, a small open source library that we can maintain and we can trust on, that it's not going to be outdated, it's not going to be unmaintained by a third party. It's a dependency we trust, and it's small, and it has all the features we want. So that's what we're calling Metal.js. So basically, Metal.js would be the substitute for YUI on the new Liferay. So just to show you a little bit of what we can do with Metal.js. So I don't know if you've seen this before. There was a talk earlier on by Chema, and he was talking about how we've added ES6 to Liferay. So this is something that people can use now, and it's something that JavaScript developers are really happy about. What is ES6? For those of you who haven't heard about this. ES6 is basically the new version of JavaScript. So this is going to be implemented on browsers real soon. For now, this doesn't work on browsers, but I'm going to get to that. And it adds really cool features that all browsers are going to support. One of them is file dependency management. So that's something we definitely want, like I said before, and that's going to come for free from the browsers. So if we're doing this, once it's implemented, we don't need any dependency for this. It's free, which is good. And it also adds things like class, extensions, constructor, calling super methods. And I know that if there are any Java developers here, you're going to look at this and say, what's new about this, right? But for JavaScript developers, believe me, that's like major news. And we're super excited about this. So we decided to use ES6. Now we have the opportunity, because this is going to be new technology, and it's not a dependency. It's what browsers are going to have, right? So we already have a gain with that. So as I said, though, ES6 is not supported on browsers right now. So what do? JavaScript developers are so excited about this that they developed a lot of tools that can compile ES6 to what the browser understands today. So basically, we write this way, but the browser gets the uglier way that it understands. So for that to happen, we need some build tasks. So we've already provided that on Metal.js so that you don't need to know about the details. I'm a little out of breath, sorry. Okay, so we have a lot of tasks that you can run on your command line, and it's really simple. You just run go build, and it will build everything for you, and you don't need to know about what's going on in the background. And we have a bunch of tasks for that. So besides that, we've also added HTML templates. So in YUI, if you've used it, you're going to know that you have to concatenate strings, which is so bad. Like, no one likes that. It's terrible code. It's hard to maintain, right? So we want to do the cool stuff. So we decided to use templates. And the idea is that Metal can support different types of templates, because people like to use different types of templates. Right now, we support soy templates or closure templates. They're the same out of the box. So this is more or less what it looks like. It's a template. So basically, you just like define a template, you define its parameters, and you just write HTML. And it looks like HTML. It's easy to maintain. And you have more control than if it was just HTML. But at the same time, it's really simple what's going on in there. It's not like concatenating strings, which is really, really hard to read. So because we're using templates, we get a lot of stuff for free. So for example, we managed to add this feature of automatic repainting, which is really cool. So basically, when you have a template like that, if you look at it, you can see that we know, just by looking at the template, that it depends on something called footer content. That's a state of our component, right? So we know that whenever that state changes, this part of the UI is probably going to change. So that's what Metal.js does on the background for you. So you don't need to have any code that listens to attribute changes and then updates the UI, because we already look at the template, and we do this automatically. So I'm going to show it to you in a demo later. I really don't have any voice left. OK, so I'm going to show it to you in a demo later. And it's a really cool feature. And finally, the reason why we chose soy to start with instead of handlebars or underscore is because soy templates can be compiled to JavaScript, and they can be compiled to Java. And that's a huge win because, again, progressive enhancement, what I talked about earlier, server rendering, right? If we want the server to render and the client to render, we need to make sure that both of these are the same. And this is really hard today because you write some template on JS, and you write the same thing again on Java. It's duplicate code, and they get out of sync all the time. But if you're writing soy templates, they're never going to get out of sync because you're compiling the same code for both languages. And so JS uses a soy, and Java uses a soy. And they're always exactly the same. So your progressive enhancement is going to be perfect, which is really cool. And I'm going to show you that too. So just really quickly, again, like we said, we wanted a small size thing because we're going to maintain that, and because we want to have a very small dependency added to Portal. So it's a lot smaller than what we had shown before. And we've also cared a lot about performance as well. So we did a lot of experiments to make sure that we were doing the right thing when building Metal. So for example, we did experiments comparing Metal to YUI, because that's where we came from. And we also use React, because that's another library for UI components. It's a new library. People like it. And it's known to be fast, right? So we wanted to compare ourselves to what people like out there, and at the same time, to what we had before. So we need to be better than what we had before, and we need to be close to what's out there right now. So we did a lot of experiments. This first one that I'm going to show you is the first render. So the page is blank. I'm rendering a component for the first time. Is that OK? So at the first time, you look at this, and you see, wow, YUI is so much faster than React. And that doesn't sound like right. It's just like weird, right? So what happens here is, this is the first render of the component. That's not its whole life cycle, right? It's the first time it's rendered. And React, for example, it doesn't just render the component. It prepares itself for a lot of things that are going to happen later. It prepares a virtual DOM, and then it does comparisons later so that updates will be faster. And I'm going to show you this later. And Metal.js does the same thing. We are very smart about updates. And to do that, we need to have some kind of processing on this first render. So we'll lose here to win on the most important parts that are going to come later. And YUI just concatenates strings. But like, if I add here raw JavaScript, it's going to be even faster than YUI. That doesn't mean we should use raw JavaScript, right? So let me show you the other parts that are really cool. And this is why we're going to get it getting faster than YUI. So decorating. Decorating is what I was talking about, progressive enhancement, right? So if something is already rendered on the page, and I'm creating a component, it's going to reuse what's already rendered as much as possible, and it's going to add behavior instead of repainting, because it's going to see that it's already there, right? So when you run all three again, you see that YUI is much slower. Metal.js can be a lot smarter than YUI to do this, and React is smarter because it uses virtual DOM, which is a big dependency, right, that we don't have. And finally, this last one is really interesting, which is updates. So whenever state updates changes on your component, the UI needs to update as well. And so if you look at this, you can see that YUI is a lot slower than this. And we have automatic updates that just update what's necessary. So it's really smart, and it's really fast. And finally, really well tested. So we made sure that we have almost 100% coverage for everything. And we have a continuous integration. Yeah. So our continuous integration makes sure that the tests are always passing on all browsers, all these browsers here, every commit. So just really quickly, I talked about Metal.js and Crystal components in the beginning. Crystal components are, like I said, Metal.js is going to be the foundation. So it's basically YUI, right, for us now. And Crystal components are like what we had before for AlloyUI. So these are the components, the UI components, built on top of Metal. We decided to change the name from AlloyUI to Crystal, just so people don't get confused, because it would be the same name, but it would be a completely different code base, right? But they're going to be the same components. So we already have a few built, and we have more on the way that we're developing. So we're porting one by one so that they'll be using Metal.js instead of YUI. And then we're going to add them to Liferay. So let me just quickly show you the demo. Do I still have, how much time do I have? Does anyone know? Just to make sure that I have time for this. So I do time. OK. So let me just show you a few quick demos. This is like a modal demo. Very simple component, right? I made a real simple modal to show you. It just has a header, body, and some footer buttons. So if you look at the code, I'm going to get, now that we're using templates, we have a JS and a soy file, right? So my soy file, pretty straightforward. You can see here, I just have templates, and I have a header, I have a body, and I have a footer, right? This is just soy syntax. And it's really simple to learn. And the JS has no JS. This is just creating a component, extending from our soy component, because it's using soy templates, and it's exporting itself, so people can use it, right? So it has no logic whatsoever. But like I said, automatically, it will already know how to update itself. So if I look here, let me see if it's big enough. You can see here, right? So Modal, let me put this. I think you guys can see, right? So Modal is just a variable that I put on window, which represents this component. If I look at Modal body, I didn't create this on JavaScript, right? But I can see that it's the content of my body. And whenever I change it, so if I just do Modal body Maíra Bello, because I'm very narcissistic, then you can see that it automatically updated. And I have no JS for that. So it's really simple to do your updates on these components. It's a lot less code than having to listen to the update and then do the update yourself. And also, I don't know if you know about this feature on Chrome, but you can, if you select this show paint rectangles here, and you do some change, you can see exactly what pieces of the page changed with that piece of JavaScript. So for example, if I just put Maíra here, you can see that the only thing that was repainted, let me do the other one again, is the middle, because that's the only thing that changed, right? And if I just set it to the same value again, nothing's going to happen, because it knows it shouldn't change anything. It's the same thing that was there before. So that's what makes the updates really fast, and that's why the numbers are what I showed them to you. It's really fast. OK, so one more demo. So I have here a bigger example. I have a whole page, right? A whole site built on Metal.js. And here, I'm just rendering everything from the server. So when I open this, I'm just getting my server to get the compiled soy file. And it's getting its result, and it's sending everything together as the HTML to me. So if I click here, nothing's happening. You see there's like an arrow. It should be clickable. Or it seems like there's no JavaScript going on, because I haven't run any JavaScript yet. But if I come here, and I get the same component that was rendered on Java, I can just decorate this page, and everything will work without repainting, which is really cool. So here, the name of my component is docs. That's just what I named it. And I'm just going to create a new instance of docs, and I'm going to say that the element is, I'm going to pass it selector to the element. So if I just wanted to render this, I would call render, and it would render it from scratch. First render, like I said. But I want to decorate. So if I just call this, now all the JavaScript is here, you didn't notice anything happening on the page, right? And now I have tooltips and a lot of stuff that I didn't have before, which is really cool. And just so that you don't have to take me on my word, I'm going to show the paint rectangles again. And I'm going to refresh this. And you can see that nothing was repainted. So it really just noticed that everything is the same as it should be and just added the behavior without repainting, which can be really bad if you repaint because it can flicker and it becomes lower without any necessity, right? So, and this is basically what I wanted to show you as a demo. So yeah, and everything is open source, just like AlloyUI was. So we have, if you go to Metal.js.com, there's a lot of information and a lot of documentation on how to do this stuff. And you can see all the code in GitHub, as well as all the Crystal components. They're all on this page as well. And they're going to be added to Liferay. So on Liferay 7, they should be there available whenever you want to use it. And some of the components we already have been ported, and they will be already working with Metal.js. And so the progressive enhancement will be really good, better than it was before. So, yeah, do you have any questions? Yes. Okay. Thanks. No questions. Yeah.
So we still have about 3.5 minutes. Anyone have questions? Oh, okay.
Does it mean in Liferay 7 Metal.js will replace Alloy?
Yeah, that's the idea. But so from what I understand, so I work mostly on the open source projects, right? So outside Liferay, I'm not the best person to know the details of Liferay 7. But from what I understand, Liferay 7 will still have YUI for a while, because we won't have time to port everything for Liferay 7. It's a lot of work, right? But with time, we're going to keep porting things, and then we will be able to remove it by default. And whoever wants to keep using YUI, they can still add it. Like, you can add Angular and Ember, anything you want. But in the future, the idea is that it's going to come with just Metal and not YUI anymore, so that we have maintainable code.
Thank you.
Any more questions? I think that's it.
Okay. Thank you very much. Oh, okay.
What's the expected compatibility metrics for browsers?
For what? Sorry, for browsers?
Oh, yeah, compatibility.
So
I don't care about Chrome, Firefox. I just want to know Internet Explorer.
Yeah, exactly.
That was obvious.
So like IE, we've dropped 8 for a while, I think, from Liferay. So it's 9 up,
9 up.
and the mobile browsers too. So this is basically the map we're using for mobile browsers. That's why these are the ones we're always running the tests on.
Okay. So we can use Metal.js as an excuse to completely remove 7 and 8.
Yeah.
No, Liferay does not support that.
Any excuse is valid. I know.
Thank you.
Okay.
Yeah, just wait until someone wants you to use IE6 again.
No. Yeah, if you want an excuse for that, no one's going to want that.
Anyone else have questions? Doesn't seem like it?
Nope.
All right. Thank you very much, Maíra.
Yeah, thanks.